All right, we're going to work on another problem where we are finding the vertical, horizontal, and oblique asymptotes. Our function this time, well, it says t of x, so we should say t of x. T of x is equal to 2x cubed divided by x to the fourth minus 16. We should factor this thing first. So the top, there's nothing to factor, but on bottom, it's a difference of squares. It's going to be x squared minus 16, not 16. The square root of 16 is 4, so it's x squared minus 4 times x squared plus 4. And then what we're going to do here, well, the first one is also a difference of squares, so it's going to factor again to x minus 2 and x plus 2. But x squared plus 4 is not a difference of squares because it is not a difference. It's not subtraction. So that's how our function is going to factor. Nothing cancels here. So if nothing cancels, that means we just set everything equal to 0. So when we're finding the vertical asymptotes, right? So our job is to find the vertical asymptotes. What we are going to do is set the denominator equal to 0. So it's going to be x minus 2 times x plus 2 times x squared plus 4 is equal to 0. Let's split all those up. Either x minus 2 equals 0, x plus 2 equals 0, or x squared plus 4 equals 0. Well, over here on the left, we can add 2, x equals 2 is a vertical asymptote. Subtract 2, x equals negative 2 is a vertical asymptote. Here, x squared plus 4, we can subtract 4 on both sides, and then we get x squared equals negative 4. We have a problem when we take square root on both sides, but don't forget to put a plus or minus sign. The square and the square root cancel. We get x equals plus or minus the square root of negative 4. Well, this is not real. If it's not real, we don't care about it. So we don't care about it. It's not real. Our asymptotes are x equals 2 and x equals negative 2. There are two asymptotes here. We're going to jump over. It's x equals 2 comma negative 2. 2 comma negative 2. X equals 2 comma negative 2. And remember, we're typing those as equations for the homework here. Ooh, they didn't like it. Let's see. Type as an equation, use integers or fractions for any numbers in the equation. So did they want comma? Did they want comma x equals negative 2? Oh, no. All right, let's go back and look, make sure I didn't make any mistakes. We didn't make any mistakes. Those are our vertical asymptotes. Nothing cancels on top and on bottom. Wait. Are they asking for the vertical asymptotes here? Oh, you guys see what happened? This is why you gotta be very careful. The function has one vertical asymptote. Well, that's a lie. The function has two vertical asymptotes. The leftmost one is x equals negative 2, and the rightmost is x equals 2. Okay, so always a good idea to check your math, but with MyLabMath, sometimes you just got to check what you put, like where you put it in, right? All right, so let's do the horizontal asymptotes. The horizontal asymptotes over here. We're going to go back and look at the original. So the original, we're going to find the horizontal asymptotes. Find the horizontal asymptotes. We have tx equals 2x cubed divided by x to the fourth minus 16. The reason we're choosing the unfactored form is because, hold on, that looks, it's because we want to look at the degree. So the degree of the numerator here, the degree of the numerator is 3. Well, what's the degree of the denominator? The degree of the denominator is equal to 4. So this time, the degree of the numerator is less than the degree of the denominator. And we call this case 1. Case 1 is super nice. The answer is always y equals 0. When the degree of the numerator is less than the degree of the denominator, the answer is always y equals 1. Sorry, y equals 0. Y equals 0. So our answer here for the horizontal asymptote is y equals 0. So the function has one horizontal asymptote. It's y equals 0. All right, let's check it. All right, and if it has a horizontal asymptote, it doesn't have oblique. Remember, oblique asymptotes are case 3. Oblique asymptotes are case 3. So there we have it. We're going to stop the recording.